Okay, welcome to our class today. I'm Melan Wafula. We are going to discuss today on retaining walls. I believe all of you are in class. So, we are going to discuss on retaining walls, and I want to share my screen with you so that you can be able to see what we're going to discuss. Let me share my screen. Okay, as you can see, are you there?
No, not yet.
Okay, I'm saying we are going to discuss general building construction, and under it we are going to discuss on retaining walls. So I've shared my screen there. So as you can see, we have retaining walls, and we have the major functions of retaining walls, which is to act as an earth retaining structure for the whole or part of its height on one surface. Most small height retaining walls are built entirely of brickworks or a combination of brick facing and blockwork or mass concrete backing, as you normally do it on the site. Now, to reduce the hydrostatic pressure on the wall during construction from the groundwater, an adequate draining system in the form of whip holes should be used so as to retain your ground. So we have small height retaining walls. So I want one of you to read what is on the screen. Tony,
Yes, madam.
yes, you can read what is on the screen.
On, on retaining walls, actually, I can see it's a half page. It's a half page. You cannot open the whole. So, small height retaining walls. Small height retaining wall. Retaining walls must be stepped, and the rule of thumb quick retaining is for height to lie between 2 and 4 times the wall thickness. Stability is checked by applying the middle third rule.
Yes.
Uh, Down there we have a diagram illustration. It has a middle third, the active pressure acting on the retaining wall, which is equated as P. Then we have another reaction force R below the footing of the retaining wall. A reaction under wall to fall within middle third. Then we have a triangle, which is a triangle of forces P and L drawn to scale and direction, closing line of triangle given magnitude and direction of R. Thank you.
Thank you, Tony, for leading us in that session. And I believe all of you have seen what are the small height retaining walls. So, want to see typical details of a retaining wall. As you can see, you have the retaining heights. These are sample of a foundation. Have you seen? So,
Yes, we can see.
yeah, as you can see,
Yes.
yeah, we have withered coping
Yes.
stones, previous membrane over the granular backfill. So I would like you at your free time to go through this diagram and draw it. Do more practice so that you can get used to it. So we have medium height retaining walls. Kiprono kindly lead us through this page.
Okay, medium height retaining wall. Retaining walls up to 6 meters high can be classified as medium height retaining walls and have the primary function of retaining soil at an angle in excess of the soil's natural angle of repose. Walls within the height range are designed to provide the necessary resistance by either their own mass or by the principles of leverage. The actual design calculations are usually carried out by a structural engineer who endeavors to ensure that 1. Overturning of the wall does not occur. 2. Forward sliding of the wall does not occur. 3. Materials used are suitable and not overstressed. 4. The subsoil is not overloaded. The fifth one, in clay subsoil, slip cycle failure does not occur.
Yes.
I hope I'm done.
Yes, thank you, Kiprono. Now discuss of the medium height retaining walls, and it is a role that is done by structural engineers. And for an engineer to ensure that that retaining wall is stable, he or she should follow the below 5 steps. So these are typical details of the retaining wall, and I'll give you an assignment so that you can go and do more of the research about it and get in touch with it. Yes. So next we're going to look at factors which the designer will have to take into account when designing a retaining wall. So first factor to consider, we have nature and characteristics of subsoil. We have height of the water table, and I believe all of you when talk of the water table remain the hydrostatic pressure, which can affect the bearing capacity of the subsoil. Then we have the type of wall itself. We have to consider which type of wall that we're constructing. Then we have the materials that will be used in the construction of the wall. So as you can see, these will have retaining walls terminologies. We have the surface, upper ground level, we have the rear face. I believe all of you are there.
Yes, we are there.
Yes, madam.
Okay. Now, let's look at the earth pressure. Is Amos Mwangi with us?
Yes, yes, madam.
Okay. Yes. Lead us through the earth pressures of the walls kindly.
This can be one of two forms, namely active earth pressure. These are those pressures which tend to move the world's weight of the earth, between plasma and hydrogen.
Almost
and the
answer the
hydrostatic
please.
pressure. The aerator can be reduced by including subsoil drainage systems behind and or through the wall.
Yes.
Passive earth pressure are reactions or equal and opposite force to any imposed pressure and persisting movement. Yes,
Yes.
madam.
Yes, those are the two types of earth pressures. And thank you, Amos, for leading us in that. To have the active earth pressures and the passive earth pressures, just from the word active and passive. So we can see we have the typical examples of the earth pressures. As you can see, we have the active earth pressure behind wall, that is wedge of retained earth plus any hydrostatic pressure. We have the ground pressure of the subsoil reactions. We have friction between the base and the ground. Then we have passive earth pressures in front
Yes,
of
and have
the
some
wall.
dear funders. That would present.
So next we're going to look at the mass retaining walls, and we have Kennedy Mwangi in our class. So he will lead us through the mass retaining walls.
These wall rely mainly on their own masses to overcome the tendency to slide forward. Mass retaining walls are not generally considered to be economic of a height of 1.8 meters. And when constructed of brick and concrete and 1.1 meter high in the case of natural stone. Any mass retaining wall can be faced with another material but generally and any applied facing will not increase the strength of the wall and is therefore only used for aesthetic reasons.
Yes, thank you. From the word itself, mass retaining walls, this is the mass that is applied on the walls, so the wall should be able to overcome its tendency to slide forward. So lastly, we are going to discuss on the cantilever retaining walls, and these are the walls that are constructed of the reinforced concrete with an economic height range of 1.2 to 6 meters. They work on the principles of leverage, where the stem is designed as a cantilever fixed at the base, and you see that the base is designed as a cantilever fixed at the stem. In cantilever retaining walls, you have several formats, which are in possible and in most cases a beam, which is placed below the base to increase the total passive resistance to sliding. And cantilever retaining walls, when you go to the field, they normally apply in the field where we have maybe weak soils so that to give it strong support. So we have the typical details of a cantilever wall. As you can see, it has this one has a height of 4.2. Then down there we have 450 millimeters. Then you have the main bars. We have the previous membrane over the nominal. We have the main bars. Then we have concrete. We have to say that the concrete ratio in cantilever should be 1 to 2 to 4 of 20 millimeter aggregate. So I believe that will mark the end of our lesson today. Is there anyone with a question?